Let's now look at the sensitivity report. Okay, sensitivity, there are three kinds of sensitivity that are possible. Solver gives us only two sensitivity reports. One is for the objective function variable cells, okay, and the other is for constraint. So you'll have one row for each decision variable in this section, then you'll have one row for each constraint. And it doesn't include this because it is in horizontal format, not like the vertical format. So if you want sensitivity report for these constraints also, you have to set them up in vertical format like this. And usually the sensitivity report for constraints is more for resources rather than uh, demands like constraints of this type. But if you want sensitivity report for this also, then you have to set it up in a vertical fashion. Okay, so what is sensitivity for the objective function and what is sensitivity for constraints? Now, first off, the concept of sensitivity for the objective function is completely different from the concept involved in the constraint. So you have to keep these two things separately. They have the same kind of feel because it gives you allowable increase and allowable decrease for the coefficients. So here for decision variable, the objective function coefficients, remember, is $80 per unit for basic and $129 for XP. That was our objective function. Okay, like that. So $80 and $129. Then what happens if it changes? It's not $80, it's $70. Or if it is not $129, but it's $140. Will that change our optimum solution? So that's what sensitivity for the objective function coefficients gives us. So let's look at the graph. Okay, so this was the graph that we had made, and with the ISO profit line we determined that that is our optimum solution, right? So if we change the objective function coefficient, the profit margin, okay, 80 and 129, okay, if you change that, what will happen? Okay, those two numbers give us the slope of this line. So let's assume that we will change only one number at a time. Okay, so we'll keep the 129 fixed. So we change the 80. So if you change the 80, then what will happen is this line, the slope of this line will change. It will become either more vertical or less vertical. Okay, so if you change only a little bit, okay, if it changes just a little bit, then this point will still be the optimum solution. X1 will be 560, X2 will be 1200. No matter that, the profit will be different because now you're either making a little bit less or a little bit more profit from X sub 1. It's not 80, it's 75, or it's not 80, it is 95. So the profit will be different, but the actual solution, that is value for X sub 1 of 560, X sub 2 of 1200, will continue to be the same. It will not be different. But as you keep changing the coefficient, so let's assume that this is going to become flatter and flatter. So there will come a time when this line will be exactly parallel to that. At that point, what will happen is that all of these points will give you the same ISO profit. So all of these different points will be optimum. And that case is called alternative optimum solution. We'll talk about that in a little bit. But if you make it even more, okay, if it changes like that, then this will no longer be optimum, that will be optimum. Okay, so that will be the one side limit. But on the other hand, if you start increasing the if you make it more vertical, then there will up to a certain point, this point will only be the optimum solution. But when the line becomes parallel to the green line, then all points from there to there will be optimum. Okay. The profit will be different, but all of those points will be optimum. And if you make it even more vertical, then that will become the last point it will be touching. This corner will no longer be optimum. That will be the optimum. So in effect, what's happening is there is a range, okay, of change, okay, either more flat or more vertical, okay, that the slope can change. There is a range of slope for which this point will continue to be optimum. Okay, and what is that range? That's what the sensitivity analysis tells us. So here 80, okay, so let's say lower limit and upper limit. Okay. So we take the current value of the objective function coefficient, subtract the allowable decrease. Okay. Then we take the current coefficient and add the allowable increase. Okay, so let's align it. Okay. So these are the ranges, okay, and also you must remember that this is taken one at a time. Okay, so if you keep 129 fixed, you only change 80, then the coefficient can go down all the way up to 0 or go up to 107.5, and in that range this optimum solution will be optimum. It will be 560, it will be 1200 exactly. The profit will be different because now you're making either less or more profit from this 560. You will make the same profit from XP, but the profit that you make from the basic will be different. So the total profit will be different, but the optimum solution will be the same. Now if you fix the profit margin of basic at 80 and allow the profit margin for XP to change, then okay, the lower limit is 96. So from 129 it can go down up to 96. Okay, or this is a very large number. Okay, it is positive infinity. 1e plus 30 means 1 times 10 to the power of 30. So this is a very large number. So if you have a very small negative infinity, then it will be 1e minus 30. Okay, so 129 plus 1e plus 30 will be 1e plus 30. So it's a very in other words, there is no upper limit. Okay, so from 129 it can go down up to 96, or on the upper side there is no limit. Okay, in that range, again this optimum solution will continue to be optimum. It will still be 560 and 1200. Okay, but the profit will be different, and this is assuming that 80 is fixed. You're not changing that at all. You change, 129 changes, and if it changes within this range, then this will be optimum. But if it goes outside this range, now you have to solve the problem again. So that is the sensitivity analysis for the objective function coefficients.